So in the last video we looked at the basic rules, and we had a object located way out here. Now in general you can use those three rules to figure out any object at any point, but in practice there's kind of some tricks that apply to what happens when the object is in certain places. So, for example, if we have an object right here, this happens to be halfway between the center of curvature and the focal point, how do we draw that? Well, we can't draw a ray from the tip of the arrow to the center of curvature and then to the mirror. It's going the wrong way. Now, depending on exactly where the object is, you may or may not be able to take this point, and instead of going from the tip to the center of curvature, go from the center of curvature to the tip of the arrow and then to the mirror. In other words, you can see I'm going to start here. Now, what we're imagining is a ray of light that starts at the tip of the arrow and follows this path to the mirror and then back along itself. Now, if I had put the object closer to the center of curvature of the mirror, then we would have had something like that and it would never have hit the mirror. Well, does that mean you can't use that line? Well, technically no. You can imagine that the mirror is out here somewhere. You might have to trace out more of a circle. But the reality is that these rules for the reflected ray really should only be used when you're close to the principal axis. So paraxial is para-axial. One of the A's is dropped because reasons, I suppose. Now, so if this is too close to the center of curvature, you just don't choose to use the ray that I drew there in red. Instead, you use the other two rays. You only need two reflected rays to locate an image. So now I have my nice grid here, which is nice. If you're working on one of the worksheet papers where there's no grid lines, I suppose I could fix that if I figured out how. You can just eyeball it. Again, these are approximate. We're trying to get a conceptual understanding of what's going on with the reflections. So, ray of light comes from the tip of the arrow parallel to the principal axis until it strikes the mirror. Strikes the mirror. Hits the mirror. Now just darkening that because I guess I felt like it. So from this point, parallel ray reflects through the focal point. Now one of the things you'll notice, since I could use that red, well, it doesn't have to be red, I suppose. Well, I don't suppose, I know. It doesn't have to be red. The ray through the center of curvature, these are going to intersect way the heckles out here. All right? Now, if I have my third ray, again, saying if this ray wouldn't work, I can use my green ray, and I really shouldn't refer to these by colors because they're just, colors are random. So from the point, or from the tip of the arrow, I should probably get to the tip of the arrow, not the middle of it. Tip of the arrow, through the focal point, going to nudge that down, tip of the pencil, on the focal point, on the tip of the arrow, draw until it hits the mirror, and if you go a little too far, that's okay. Now from this point here, where it hit the mirror, it's going to be parallel to the principal axis. Now if I did this reasonably well, these three rays should be more or less crossing in the same place. And you can see I drew my green line a little bit high there, so that not quite, but they're fairly close. If I'd been a little carefuler with my green ray, I'm adjusting our vocabulary, I suppose. So I'm going to say, okay, let's say we couldn't use that red ray. Well, again, the ray through the principal axis, or the ray through the center of curvature. Well, my object here is like this. Okay? So where the rays cross is the tip of the arrow, and then the other end of the arrow is on the principal axis, and it's just perpendicular to the principal axis, assuming this is perpendicular, which it always will be in the examples we create, because otherwise it gets a lot complicated. So this is an example of an object between center of curvature and the focal point, produces an image out here. Now, you can see these reflected rays really are out here, and so this would be a real image. It's upside down, so we can call that inverted. And now this is 2 boxes high, and this is 3 and change, and 3 is more than 2, so this is actually larger than the image. So the video is going to flip here, and you'll see the example of the object, the yellow paper arrow, really in the middle there, not exactly in that spot, but close enough. And if you look at the object, you'll see that look at the image, you'll see that the image of the arrow is indeed larger than the object. Now remember, when you're looking at the image, you're actually looking at it like this. That's the camera view. So you've got the paper yellow arrow, the mirror, and then the object, and you can predict the image. That's the image, not the object. You can predict the image is going to be pointing to the right if the object is pointing to the left. The image will be larger than the object.
And that's exactly what we have. We have an image that is pointing to the right, even though the object is pointing to the left. It is longer in the horizontal direction than the object is. Again, there's no distortion in the vertical direction because the cylindrical mirror doesn't have any curvature in that direction. Also notice that you can see in the image that the object really is between the center of curvature and the focal point. It's not exactly where I had it, but that's not really the point.